find that to be the most interesting as a software person. So as a software person, right, you're used to basically working on your laptop all the time, working on your desktop all the time, and not actually interacting with the physical world in any way. And what we're able to do now with this concept of Internet of Things is we can truly interact with the physical world, and it can interact with us. And that's a fundamentally different paradigm for a software person. We're so used to being, okay, I got a keyboard, maybe a mouse, and that's the only physicality to the world at large, right? The mouse is the most physical object that we deal with typically as software people. In this case, I have a whole, set of different things, hardware pieces here that we'll look at throughout the session. So we got to go kind of quickly. This is kind of a JavaScript-oriented session because I assume that this particular audience will probably be more interested in the JavaScript aspects of things. I do this presentation with Apache Spark and Apache Camel, Apache ActiveMQ, and a bunch of Java stuff as well, because actually my background is more Java. My day job, by the way, is for Red Hat. I'm specifically in product management, most historically around our tool set, which is an incredibly popular tool set that we have, Eclipse-based tooling for any kind of Java or mobile application development, as an example, for the Eclipse platform. But what I'm moving to now is just being a full-time presenter, because that's what Red Hat wants me to do at this point, is go out and talk to people. So in the world prior to software, prior to software eating the world, famously quoted by Mark Andreessen, right? We used to actually make physical things. We used to purchase physical things. We used to ship physical things. And the world used to have physical things. I was at the Java user group giving a presentation not too long ago, Triangle Java user group, and as well as the Atlanta Java user group. And I asked, how many people, actually work for a software company or a financial services company? And between financial services and software, 80% of the hands went up, which is kind of mind-blowing if you think about it. So these are people who don't make physical things, right? Software manufacturers manufacture software. Financial services organizations run a bunch of transactions. They don't actually manufacture things that often anymore. But there's still a good number of people in the world that make things, and we still consume things as buyers. So there are still people out there who are actually doing some very interesting in the thing universe, if you will. My favorite one on this is the Disney Magic Band. It's reported as actually spending over $1 billion in infrastructure, IT infrastructure, to support that little band that goes on all the people now who visit the park. That little band actually has two little communication techniques built into it. It has an RFID and a 2.4 gigahertz radio as well. So they can know when you scan in to get into your door or onto a ride, or I want to buy popcorn. And they also can know where in the park you are by proximity based on the 2.4 gigahertz radio. And this means they can now have let's say you lost your child, they can find your child as an example. That's an easy one. And that's actually one of the demos I often do with my beacons. I have a whole bag of beacons here. So 2.4 gigahertz Bluetooth chip in the beacon, and you can use that to track people, track moving objects around a big facility as an example. But also you can personalize the experience now. That's the goal for Disney, is to personalize your experience at Disney. So if you really love Buzz Lightyear versus Han Solo versus, Spider-Man or something like that, right? You would have the experience that you're interested in, because I want to meet Han Solo on the ride. I want to meet Buzz Lightyear on the ride. I want to meet, Pocahontas on the ride, whatever it is, right? Whoever your favorite character is, you can then interact with that character as an example. So that kind of technology is really becoming pervasive. And the Disney Magic Band is just an example where they just took the electronics, inexpensive electronics, most of which I have here on this table right now, and found a very clever way to use it. So I'll go through these slides pretty quickly so we can actually get to more of the demonstrations, and we want to have enough time for any questions that you guys might have. But one of the things I like to do is put things in perspective. And this is what I used to do, build software for back in the old days. So I called it CHUI, Character UI. So it was VT220, VT100, 5270, 5250, 3270, block mode. This is your IBM mainframe style things, your VAX minis, right? We used to actually build character applications. They weren't GUIs, if you will. They weren't graphical applications. And what actually happened was if someone, let's say at the plant level, the plant manager determined they needed a new product, they needed a new component part that your company sold to them, they would get on the phone and call the sales rep, who would then type up a fax and fax it into the back office. And the back office person would enter it into the green screen application, into that mainframe terminal, let's say, and then out the other end of that system, what the product would ship. So it was actually required 3 humans to be involved, and one of which was a phone call, the other which was a fax, and then the data entry is done twice. And so it was easy to make a mistake in that world, not to mention it took a lot of time. And then we added the GUI, right? The graphical user interface with the Microsoft Windows when it came out in the early 90s. And so we eliminated a step. We said, hey, Mr. Sales Rep, don't fax in your order, right? Do that on the Windows machine we just gave you, the Windows desktop we gave you. You type in the order, and then the order goes into the system bypassing that back office person. So we eliminated a person. And then we maybe said, hey, let's do this web thing in the late 90s or early 2000s. And so the plant manager at the customer site could then enter the order themselves, right? They could go to the web browser and see, okay, here's the product I need from that vendor, type in my order and pound it into the system. And then we got to the mobile solution. Many of us are not yet ready for mobile, right? At this day and age. In 2015, we're not quite ready for mobile. We're still mostly doing desktop web, is my guess. But for some people, mobile. So now the plant manager can enter it directly on their phone without having to go to a desktop. They're unchanged from their desktop now. They can walk around, see that they need this product, use their phone, maybe barcode scan it, and then say, that's my order. In the future, though, there'll be things talking to other things. The machine itself will know it's out of a particular part and needs new product. It'll make the order for itself. No humans involved whatsoever. And the real reason I'm suggesting this is not because I want to eliminate people's jobs, right? That's kind of the nature of the beast and what we do anyway as software professionals. But it eliminates errors. The machine knows exactly how much quantity and what particular part it needs right now. Why does any human need to be involved in interpreting what that machine needs? The machine can talk directly to our machines. It's kind of the idea. So at the highest level architecture, right, you have the concept of sensors. I have a whole bunch of sensors here. Sensors might be battery operated. They might be wireless. They often are bridged through some form of gateway. If they're a wireless type sensor, they're going to be bridged through some form of gateway. You see that right here. And then they have to go through some sort of high volume ingestion system. So like in my case, I use ActiveMQ, Apache messaging broker, Apache ActiveMQ. And that's a way to basically suck in vast volumes of sensor readings on the fly. So I could have all these sensors streaming data into this laptop right now, and that's one of the demos I sometimes do. We'll see if we can get that working. But you have to have a way to ingest all that data, to absorb the volume of that data. And then you got to have some form of analytics engine that determines what to do with that information. By default, this is just raw message data. But then I have to have some analytics, some streaming analytics, and I use Apache Spark for this, to determine exactly what do we do about certain sensor readings. Is it getting too hot? Is it getting too cold? Is it a little bit warmer than our last year's average, right? And is that meaningful in some form or fashion? It very well could be that if it is warmer than our last year's average, we might need to start a workflow that gets a human team out to look at the problem, potential problem. Or maybe we have to integrate with other existing systems like the order processing system in our company. So we have to have some form of integration. And then maybe we want some form of dashboard to be populated in real time as an example. So I would use Apache Camel for a lot of that. So, Apache ActiveMQ, Apache Camel, Apache Spark is one style of presentation that I do in the same area. And then on the outbound side, so think of the sensors as how you read the world. And on the actuator side is how you write to the world. So I like to think of it. I'm an old school database person, reads and writes right to the database. So the sensors basically are giving me input data. The actuators are my output data. And I can use that information to write to the physical world, literally change and alter the physical world in any way that I choose to. And once you figure out this pattern, it's really straightforward to figure all this stuff out. It takes a little while to get your head around this concept, but once you do, it's not too bad. And you can kind of do almost any little gadget type thing you want. So another thing to keep in mind is the mobile phone might be used in configuration. So if, in fact, you do have a mobile application, you're a mobile developer, often now what we're going to see is an app paired with the device in some form or fashion, typically over Bluetooth. And I have a couple examples of that also. And then you can use the Bluetooth radio on the phone from the device. Like this is an interesting example. This is actually a wearable platform, right? So it's a programmable wearable platform. And actually, you can eliminate this whole wire here. I had that added on, but just the little chip and the battery, you stick that in a wristband, and now you have like 18 different sensors that you can monitor from the phone, from that device, from the person, as an example, over Bluetooth. So the phone can be very useful as its own gateway, if you will, to bridge the sensor world or actuator world back into the main enterprise world. Okay, one thing to keep in mind when you're dealing with actuators, right? You're now interacting with the physical world. You're altering the physical world. You got to think about your security in a higher level from that perspective, because it might be if you're flipping on a light, no big deal. It's just someone's lights. You might be able to irritate them, right? Turn their lights on and off when they're not paying attention. You guys probably heard there was some great hack, right? They actually altered the light sequences in someone's building to kind of like them think they're going crazy. You know, so that you could actually just change the fluctuation of, let's say, fluorescent lighting. But it's not that big a deal if it's just your lights, right? But if it's a traffic light that's specifically doing rail traffic, it's a real problem. You know, now we're talking lots of people could die, millions, if not billions of dollars in damage could occur. You want to think through the security aspects of that when you're interacting with the component. So by default, it's not hard. That's the funny part. You know, you could hack it together in the afternoon to make that traffic light for your trains interact with your software. But the problem is anyone else can hack it together, and you might be in trouble. There's also a direct connection that can be made. Let's say this bus up here. It can be make a direct 3G connection from its roving around the city directly into your ingestion system as well. That's actually a very common and popular technology right now, is 3G radios built into a lot of devices. I have a set of 3G radios on order right now that I haven't got in yet, but they'll come with a SIM card, and you'll pay $2 or $3 a month or whatever for them, and they communicate, you know, back into the mothership with their data as well, right? Whatever sensor data, actuator data that you have. So this is kind of a fun slide, so we'll spend a little time here for a moment. But this is, I separate this in microcontrollers, controllers, and embedded Linux. If you come from a JavaScript background, or in my case, a Java background, JavaScript background, I like to live more on this embedded Linux side of the house because it is a Linux computer. And the Linux computer, as an example, like it's, you know, here's one. It's on a battery right now. The battery is bigger than the Linux server, right? This is the Intel Edison. And actually here, I'll show it to you in my camera. Right, so this is the Intel Edison. So it's a Linux server on a battery. It'll run on. I'm not doing much with it right now, so it'll probably run on this battery for 4 or 5 hours or so. If I start pushing it really hard, it'll burn out the battery in about 3 hours. I went on a second.
Oh, sorry.
Yeah. So that's when I say embedded Linux. That's kind of what I'm referring to here. All right. So at a high level, you'll see these microcontrollers. There's numerous examples of microcontrollers. They all started with the Arduino Uno. This is what the Arduino Uno looks like. I say it started. There's predecessors to this, but this was an open source hardware platform. This is what's revolutionizing the space. Just like open source has revolutionized all other aspects of software that we deal with in IT, right? I mean, is there anyone here that doesn't use some form of open source software at this point, right? If you're a JavaScript person, you're using AngularJS, jQuery, React, right, or any of those kind of client-side frameworks. But there's all the server-side stuff, Node.js, right, and then all the stuff from Apache on the Java middleware side that I've mentioned already. But this is open source hardware, and this is really changing the game. Because anybody who wants to build their own microcontroller based on this platform can copy this and make their own. And that's exactly what's happened with like the light blue beam. We'll show you those in a second too. But this is a Bluetooth-enabled Arduino at this point. And then I also have my particle, this is my particle IO photon, a Wi-Fi enabled Arduino. All right, so you can do almost anything now in this space because of these nice guys here from Arduino. Basically a bunch of college kids and a college professor out of Italy. They invented this platform. Do you also see the Pro Mini here? So this is an Arduino, this is an Arduino. Same exact power and capability, but this is a $10 chip that's the size of 2 postage stamps. All right, and then you also have this Arduino Uno here. So there's one here in the middle I'd call attention to. It's the Tesla. That's actually a JavaScript-enabled microcontroller. It is not yet shipping. Real quick. Let's see here. Yeah. So the Tesla is pretty cool. I haven't received one yet. We received pre-orders for $35. Ships in November. What you'll find is one of the toughest things about doing hardware is waiting for the hardware to arrive at your doorstep. With software, right, we just download it, we go to GitHub, we get cloned, boom, whatever, right? We download it from Apache.org or wherever we get it from, and we have it instantly, and we can start working with it instantly. In the case of hardware, you will often have to wait months to get the hardware, not days for shipping. There's some things that only take a couple days from SparkFun or Adafruit, but often your wait time is months, all right? So just keep that in mind if you say, oh, I'm gonna do an experiment this weekend. No, it's probably 3 weekends from now, right? So you got to plan ahead. You got to buy the kit you think you need and hopefully buy everything you need. And hopefully a month from now, you'll be ready to try your experiment in many cases. You just got to factor that into your thinking. It's very different for software people. Like this Tesla has been on pre-order now for several months. My photon that I have here took 6 months to arrive after I paid for it. Intel Edisons will sell out all the time. Now, Raspberry Pis are pretty common now. You can get those all day, every day. I've got like 8 of them at home now. But some of these things really are hard to come by, depending on what it is. And you will wait a period of time. Also, you may decide you want a really good deal on that product, right? You don't want to pay the $12 at SparkFun or Adafruit. You want to go to eBay and order it from China for $2. And it is that delta in price. I can get it for $2 instead of $12. Now it's going to take you 45 more days to get the shipment to occur from China, though. So you have to kind of factor all that into your thinking as you mess with this stuff. Okay, so we'll just hop back here real quick, and we'll just go ahead and start demoing some of these things. But at the highest level, look for things with connectivity. Most of the stuff in the microcontroller world has no connectivity. So the original machine-to-machine world, the embedded world, most of those folks don't do networking of any sort. And like the Arduino Uno is a disconnected device. Therefore, it's not really part of the Internet of Things. It's the thing without the Internet. And if you do want to pick up like a light blue beam, know that it's Bluetooth based. And you got to find a way to bridge Bluetooth to the public Internet, as an example, which I'll do through my Edisons. And there's also like the TI sensor tag, which I have here, this little rubber guy here. That's a great little device. It's you know, it has 10 different sensors in it. It costs about $29, but it also uses Bluetooth or 802.15.4. And so you decide, you know, what networking protocol do you want to bridge into this guy as an example. There's one here that's very notable that has lit the world on fire in the last couple months. Is the ESP8266. It's $4. So it's basically something similar to this $19 package, but it's $4 instead. And that's one-off price. You can get them in bulk for like under $3. So that has really kind of got people super excited. The idea that you can have a Wi-Fi radio and enough processing logic. It actually runs Lua as its native programming language. Most of these things run C, but in that case, you run Lua on that guy, and you can actually put a little HTTP server right on it, and you can interact with it through REST calls, just like you can for this, but this is Wi-Fi based. This is $19. On the Linux server side, the Raspberry Pi, of course, is the most notable, what people know about. But I really like my Intel Edisons. It has a built-in Wi-Fi and Bluetooth as an example. The Raspberry Pi, you would add on the Wi-Fi and Bluetooth. There's another one out there called the BeagleBone Black. It's notable because it's actually an open source hardware platform also. You can actually get the schematics to it and modify it for your own needs. But there's two that have kind of changed, been game changers recently. One was the Onion Omega. It was a $25 Linux-based with Wi-Fi chip on board, and I'm still waiting for those to ship to me. So again, multi-month wait times for some of these things. And then this other one called the Chip. So interesting name, CHIP, Chip. They went so far as to use marketing dollars to help fund the hardware platform. So they're selling it to you for $9. So this is a full Linux server on a board with Wi-Fi and Bluetooth for $9. And that's game changing again. It's just like this other ESP8266. When you couldn't have done something for $50, you might do something for $9 if you think about it like that, right? You know, $50, I got to have 1,000 of these things running around all my hardware and manufacturing plants. I'm not going to spend $50 for 1,000, but I might spend $9 for 1,000. And so these guys are going to try to change the paradigm simply because they'll just use VC funding to help fund the hardware platform, which I think is pretty clever of them. And they're going to try to seed the market and steal a lot of market share, as an example. So let's actually walk through some of this stuff here on the local machine. And actually, it's a good point. Let's see if we can turn on the light. So I use Node.js pretty much for everything. So we turn the light on. Okay, so I like to use Node.js for most everything. So we got a little more light here. But let's kind of walk through some of these things in more detail, all right? The Arduino Uno, you can kind of see how big it is there. Again, not connected, and this is where you put your little pins, put your little jumper wires like you see here. It's no longer that interesting, but this is actually where I got started, as most people did. In this case, it was several years ago. So if you're new to this stuff, this is probably where you start. The tutorials are phenomenal. All the software is free. The hardware is open source. Everything's open source. It's a beautiful thing. It really has revolutionized the industry. This is the particle I/O photon I was mentioning. There's the Wi-Fi radio on top. There's the antenna built into the chip. These little guys, of course, fit down into your breadboard. Right? You would just plug this in and then start wiring away, right? And start making up what you want there. My personal faves, though, these days are like, I love this light blue beam. You can see this case, I soldered a button onto them. And I have others here that I'll show you in a second. Here's one with a sensor on them, as an example. All right, so that's a little light sensor, but he also has a temperature sensor and an accelerometer built into him. One of the things these guys are scheming up is that you could actually take this, it's so small, you can see it has a battery on the back, that you can stick it on products within a retail outlet. And as customers go over and look at that retail item, right, they just touch it. This actually, because the accelerometer built into it, sends the Bluetooth signal out. The route changes all the digital displays around the person to let them know what that product is about. So this is totally Big Brother is watching you in the retail setting, right? Oh, the cool shoe. Next thing you know, all the ads around you switch to that shoe. The Nike shoe versus the Reebok shoe or something. So there are a lot of people looking at this platform for that. This is a $29 gadget as well, again, with the Bluetooth radio built in, and it is a 32-bit microcontroller. I think 32-bit. I might be wrong. It might be less than 32-bit. But you program it just like you do the Arduino, and it's C code for this also. Here's my Edisons, but actually let's show you this Raspberry Pi right here. So this little Raspberry Pi, this is a relay, and he's plugged into my lamp, and turns the lamp on and off. And what I have is, right now, I have this Node.js program running. So I'm actually SSH'd into this Raspberry Pi that you see right here, this Raspberry Pi right here. And that's the relay that's attached to him. I also have a little servo attached to him. And then he's running a Node.js script. And then that means I can send it in messages. Like if I want to turn the lamp off, I can send an off message. So this is MQTT. This is MQTT.js. It's one of the npmjs.org things. It's incredibly popular. A guy who makes it, his name's Matteo. He's a totally awesome guy. But with something as simple as that, I can, from anywhere on the internet now, send in a message, turn the lamp on and off. It's that hard. And it takes almost no lines of code. And it's all done with JavaScript. If I want to do something like, let's do this, all right. And let's try to make this a little bit easier to see here. It's kind of hard to see everything, but we'll try that. Okay. All right, so not quite right. Got to make it where you can see it. Okay, so if you notice, watch the little propeller there on my servo. There he goes left. There he goes right. Is that an R? I can't actually read, so he goes right. Again, I can turn the lamp off, turn it on. Okay, so the point of this Raspberry Pi that I'm SSH'd into, this is actually just my desktop client, and I'm sending messages through the message broker, which is being received by this guy over here. You can see he's just reporting the messages that he sees, on, off, left, right, that kind of thing. And then it's basically using GPIO, right, the pins here on the side of this Raspberry Pi to interact with the physical world. Change my servo settings, change my relay settings. So the relay is just a electromagnetic switch. So you